In Part 6 of the Unit 1 notes, we will be covering counting significant figures. Precision is limited by the device we use to measure. Measuring devices that are more precise allow us to record more digits in our estimated value. The reported digits are known as significant figures. Significant figures include all digits known with certainty, plus one digit which is estimated. The ruler above can measure the tens place with certainty. So if we're looking at the ruler, here we can see the ones place as we go from 5 to 6, and then the little tick marks are representing the tens place. The red rectangle is approximately 5.5 centimeters, so we can see that it is fairly close to that line. But we must estimate one digit further. The rectangle appears to extend slightly beyond the 5.5 centimeter mark. So 5.5 centimeters would be an acceptable measurement. We also mentioned when we were doing our estimation lesson that 5.54 centimeters, if you believe that it was slightly below the 0.5, or 5.56 if you believed it was a little bit further, would also be acceptable answers since that last digit is estimated. All three of these digits, the two certain and one estimated, are considered significant figures. There are a number of rules that will help you to determine how many significant figures a value has. The first rule is that all non-zero digits in a measurement are significant. So for example, if we have the number 237, we would say that has three significant figures because all three of these numbers are not zero. If I had 1.897, that would have four significant figures, again because there are no zeros. So all four of these are going to count. The rest of the rules help you to determine whether or not a zero is going to count as a significant figure. Rule 2. Zeros that appear between other non-zero digits are always significant. I often refer to this as a sandwich rule, since we have non-zero numbers sandwiching a zero in the middle. So in this example, the 3, the 9, and the 4 will always count as significant because they are non-zero digits based on Rule 1. These two zeros in the middle are both going to count because they are sandwiched between the 9 and the 4. It doesn't matter how many zeros are in between those two numbers, all of them are going to count as long as they're sandwiched. In this example, 5.02, the 0 is sandwiched between the 5 and the 2. So that would count as a significant figure, and we would say that it has 3. Rule 3. Zeros that appear in front of all non-zero digits are called left-end zeros. Left-end zeros are never significant. I also tend to refer to these as leading zeros, since they are the zeros that are leading the entire number. Here with 0.008, these three zeros do not have a non-zero number in front of them. Therefore, they don't count. So the only number that is significant here is the 8. So we would say that this value has one significant figure. Now, even though these numbers are not significant, that does not mean that they are not important. We do still need to include them here, because if I didn't have them, if I say just wrote 0.8 or even 8, those are very different numbers than 0.008. So right here, these zeros are acting as placeholders. So when I say a number is not significant, I don't mean in the sense that it's not important. It is still important to have the zeros there. Here we have another example of leading zeros. We have 0.000416. So the 4, 1, and 6 are going to count. So we'd say that has three sig figs. Rule number 4. Zeros that appear after all non-zero digits are called right-end zeros. Right-end zeros in a number that lack a decimal are not significant. So 140, 75,210, those zeros on the end are not going to count. So this would have 2, and this would have 4. Our final rule also deals with right-end zeros, but this time there's a decimal point. If there's a decimal point, they count as being significant. So here 620, because I have the 0.0, both of these zeros are going to count. So I'd say this has a total of 4 significant figures. In 19.000, The decimal makes all 3 of these zeros significant, so I would say that it has 5 total significant figures. Now we are going to use those rules in order to determine the number of significant figures in each of these values. For our first number here, we have 40.7. The 0 in the middle is sandwiched between the 4 and the 7. And the 4 and the 7 would always count. So I would say this has a total of 3 significant figures. 87,009. Again, the 8, 7, and 9 will always count, and these 2 zeros are sandwiched in the middle. So everything is significant in this number. So that would be 5. Our next example is a little different. Here we have leading zeros. So 0.0, those are just placeholders. But the 9, 5, 8, 9, and 7 are all going to count. So 5 significant figures. This is a similar example. We have leading zeros again. So these are all placeholders, but the 9 is going to count. So 1 significant figure. 85.00. These are right end zeros, and there's a decimal. So that means that they are going to be significant. So this has a total of 4. Here we have 9.000000000. Another example of a right end 0 situation. So all of those are going to count. So that has a total of 10. For our last two numbers, these are essentially the same exact value. They're both 2,000, but one does not have a decimal and one does. The one without a decimal is going to be 1 significant figure, and the one with a decimal is going to have 4, because all of these count. Please make sure that you write all of these examples out into your notebook, just like any of the other checkpoint questions. All right, now let's say that you're a little confused by the rules, which would be completely understandable. There is kind of a shortcut method for determining how many significant figures a value has, which might help you. It's called the Atlantic-Pacific rule. Basically, the way that it works is that you start on the left or right side of the number based on whether or not a decimal is present or absent. Present, meaning that you start from the left side or the Pacific Ocean side. And if a decimal is absent, you would start from the right side or the Atlantic Ocean side. The first non-zero number and all numbers after it will be significant if you use this rule. So let's try a couple of examples where we're using this little trick instead of the 5 rules that we originally learned. Here I have a decimal which is present. So that means I'm going to start counting from the Pacific or left side. My first number here is a non-zero. So that tells me that everything that follows it is going to be significant. 1, 2, 3 digits. So that would be 3 significant figures. In this example, I also have a decimal present. But this time, the first digit that I run into is a 0. So it's not going to count. So I'm starting from the Pacific side. I go over, 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 and there we go. Now from here on, everything is going to be significant. So 4. And this number right here, we have 42,001. There is no decimal. That means decimal absent. So I'm going to start counting from the right side. The first number I encounter, a 1, is always a significant figure, so everything after it is going to be significant. So 1, 2, 3, 4, 5 significant figures. With this value 5,000, again, no decimal, so we're starting from the Atlantic Ocean side because it's absent. Placeholder, 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 and then we run into the 5. So this would only have 1 significant figure. That concludes part 6 of the Unit 1 notes. When we come back in part 7, we will be working through operations with significant figures.